In PowerShell, we can create commandlets directly on the command line. We've done this in previous examples by doing things like typing a string of text and putting quotes around them to make a string object. But most objects in PowerShell will be created by commandlets that you run, either on the command line or in a script. When a commandlet creates an object, the commandlet can release the object it has made, in other words, throw it away, and it's lost forever. Or it can simply pass it on to the shell as output, and if you don't do something else with it, PowerShell will format and display it as text using what can be unpredictable rules for new script users. Objects continue to exist as long as and only if something in PowerShell refers to it or has a handle for it. If nothing refers to an object, the object is lost. That is called releasing an object. If we create an object that we want to keep for later use, for example in a script, we would normally take that object and assign it to a variable. This works differently than assigning data to variables in shells like Bash. In traditional shells, when you assign data to a variable, a memory space is allocated for that variable, the variable's name is attached to it, and the data is placed there. When you put an object in a variable, what you're really doing is putting the handle or reference for that object in the variable. This can have some interesting effects. First, it means that a variable can hold any number of objects, because an object can be a single object or a whole collection of them. If the variable contains a collection of objects, we can use the same kind of array syntax to access the different objects in the collection, or the array, as we used in Bash, using square brackets and an index number. The objects themselves are stored in memory, and only the handle or reference for the object gets placed into the variable. This can be tricky because, depending on what the object is, what it contains, and whether or not it's an array, you can wind up with a copy of the data, a copy of the object in each variable, and then when you make changes to one variable, it doesn't affect the other one. Or you can wind up with both variables pointing to the same object handle, in which case changes made to one variable affect the other one because they refer to the same object. I'll give you a quick example of this. It's going to use array notation, which we haven't used yet in PowerShell. We will revisit it later, but to simply demonstrate that it can be a little unpredictable, and you need to test these things as you get used to PowerShell to find out what's really going on. It is a good example. If I take the A variable and I store a number object in it, and the value of the number object is 5, and then I make the B variable equal to the same thing as the A variable, then if I look in A, I'll see the 5. If I look in B, I'll see the 5. And if I were to add one to A and look in them again, I would find A has had 1 added to it. It's gone from 5 to 6. And if I look at B, it has not changed. The reason is, when we assigned what was in A to B to create the B variable in the first place, it actually retrieved that object, put it on the command line, and assigned it to B, which means B made its own copy of it. And what happens to A, in this case, doesn't affect B. You can use them as separate variables. On the other hand, if I make an A variable and I put an array in it, so that A has 3 things in it now, it has one object handle, one reference that refers to the whole collection of objects. If I now make B from A, so I assign what's in A to B, I'll find that B also has a collection in it. But unlike when it was the single object that got assigned, the B collection is the same collection as A. Not just having the same things in it, it is literally the same collection. So if I were to modify the A array, the A variable, to have one less element, so that the A variable no longer has 1, 2, 3 in it, it just has 1 and 2. If I look at the B variable, I'm going to find that it has also changed, and you might not have expected that. So remember, when you assign things to variables in PowerShell, you are not necessarily making a copy of the data and putting it into a variable. You are simply creating an object or collection of and assigning the handle. The rules for this get a little bit squirrely, and it may not make a lot of sense. It is really important in PowerShell to test what you're doing before you start putting commands into scripts. If you put 10 commands in scripts and 8 of them don't do what you think they do, you will be very confused trying to figure out what's going on with your script. It's very important to test each thing before you add it and make sure you know what it's doing. Another way to get our objects, other than producing them with a commandlet, is to create objects with a commandlet and place them on the command line, and then use that for another commandlet that works with it as input. In Bash, we did this by creating subshells using the parentheses around a command, which meant run the command, get the output, and put that output on the command line as text. Well, in PowerShell, we're working with objects, and the similar mechanism works. And we need to make sure that if what we're trying to do is work with the output of a command as data on the command line, that we put the parentheses around it. If I wanted to use write output to produce the object on my terminal that would be created by getDate, and I forget to put my parentheses, I'm not going to get an error, because PowerShell tries very hard to guess what you wanted, and it will read that line and say, get-date. Well, you must have wanted a string, even though you didn't put quotes around it. So it makes a string object from getDate and gives that to the write output command. So when you run this, you get the string. If I wanted the output from that getDate command to be the input used by the write output command, I need parentheses, which means run getDate. Any objects that come out from it should get put on the command line for write output to use, and then write output will operate on the output objects, producing the output on the screen that we expect to see. So the parentheses can be used to get the output of a commandlet to place on the command line. Some commandlets produce output that we don't want. For example, makedir, when it displays the object that it created, might not be of great interest to us. Then again, it may well be of interest to us. For example, if I would like to make a directory and then change to it, in Bash, I would use two commands. I would say makedir, and then I would use a change directory. In PowerShell, I can say makedir, and I can pipe the object it produces, which is the directory, to a change directory command. The change directory command won't see any input on its own command line. I didn't put anything after the CD, so it will look in the pipeline. And in the information coming from the pipeline will be an object. which points to a directory, and cd can go to it. Notice my prompt got very strange when I did that. That's because the object produced by makedir is more complicated than you might have guessed. It is not just a string with the name of the directory. It is a directory object. It's very important to remember this. In most cases, when you want to work with the makedir command, you won't want the object it produces as output. You're making the directory, you know what it is. If you're making a directory with a random name or using the output of another command, you may wish to save the output of makedir in a variable for use later. For example, I might say the mydir variable will be equal to the output from running my makedir command. So the makedir command will run, it's inside parentheses, it'll make the tmt2 directory in this case. It will produce an object that is connected to that directory, that represents that directory, a directory object, and that object will be assigned to the mydir variable, so that later I can use commands like cd to the directory object inside the variable. So always think about whether you want the output or not. Now, other things you can do with output is you can redirect it, like through a pipeline, as we've seen. You can also use the file redirection mechanisms that Bash had. I could say makedir some directory and send its output to a file. And then even though it made an object and the object was default displayed, that display didn't come out on my screen, it went to a file instead. If I were to use a command like cat, which is one of those fake Unix commands, and look at the foo text file I just made, I see the text that would have come out on my screen from makedir. Just like in Bash, when you use the single greater than sign for redirecting to a file, it overwrites the file. If I make another directory and redirect to the same file and look at what's in it, I only have the new output. If I want to append or add my output to that file, I will use the double greater than symbol. Then my output file won't be overwritten, it will have my new output added to the end of it, making it longer. So the greater than and double greater than are just like they were in Bash for our purposes, remembering that it is the output that would have been on your screen that gets sent to the file. So it will be limited by the width of your window and everything else. It looks just like it would have looked on your screen. Pipes are very similar to Bash pipes. We've seen an example of piping already. Remembering that when we do pipelines in PowerShell, it is objects that are going through the pipe, not just text. When we send objects through a pipe, it's usually because we either wish to process them some more or we wish to control where they go and what format they have. If the default output format for a directory is not what I want written to the file after makedir, I might pipe it to a command to format the data from that object, the properties in the object, before printing them to the file. The other thing you can use is simply controlling where it is sent. The greater than symbol or double greater than symbol are fine for redirecting default display of objects to files, but you might want more control over that. In that case, you might have wanted a command like out-file which allows us to specify various options or parameters to control how it is written to a file. If we don't give any options or parameters, it works very much like the single greater than redirect. But we can give options like how wide the lines are, how big the terminal window looks like it is, and other things. The out commandlets, the ones that start with out, are actually quite useful to send things various places. We've now seen out-host, which says take my output, make it text, and send it to my screen. We've now seen out-file, which by default looks quite similar, except it sends the output to a file. But we do know, because I told you, that the out-file command has various options that we can use that can change how the output looks before it gets sent to a file. We can send output other places. If we don't want the output from our makedir command at all, we don't have a need for it. We just wanted to make the directory in the file system. We don't care about the object it made. We can throw that away by piping it to the commandlet out-null. When you send something to out-null, it is discarded. Out-null simply takes all objects given to it and lets go of them. It ignores them, it drops them, and they are then deleted from memory. Those objects disappear. The directory still got made, but the object that got produced, which would have shown up as text on my screen, was thrown away. There are other out commandlets. If I wanted to print the data that was in that object, I could have piped it to out-printer and either gone to the default printer or specified various parameters like which printer to send it to, what print options to be using, and things like that. And there is another one that's actually very interesting, out-grid view, which we'll see momentarily. There are some examples on the next slide showing creating objects on the command line and just letting them be displayed, or sending them to a file, or sending them through a pipe to get rid of them. Try these commandlets yourself before proceeding further. Make sure you can see what they're making.